Hi everyone, I'm Pravash and you are watching Engineer's Fate. So before watching the video, I hope you have watched my video of compass surveying and I hope you have read this topic at least once. Means at least once you have gone through this topic and at least you have read the basic concepts from the topic. As I said, I'll only discuss the numerical concepts that have been asked in GATE examination, and I'll take the concept and I'll discuss the concepts only in the questions itself. So let's start our discussion. So first thing is that traverse surveying. So first word is traverse. So what do you mean by traverse? Traverse is nothing but it is a series of connecting lines. And why we do traverse surveying? We do traverse surveying to check the accuracy of the survey work. Is this the only application? No, there are plenty of applications why we do traverse surveying, and you can read that from a textbook. So traverse survey is of two types. So first one is open traverse and second one is closed traverse. So in open traverse means what? Means traverse from a known point to unknown point. It means what? Suppose there is a point X and I have start my survey work from that point X, and there is a point Y and I don't know about the coordinates of the point Y, but I know the coordinates of the point X where I have started my survey work. So I have started the survey work from a known point and I have ended my survey work at an unknown point, and that can be called as a open traverse. So in the closed traverse means what? Same thing. Suppose there is a point X. I know the coordinates of the point X and I have started my survey work from that point X, and I have ended my survey work at that point X, and I know the coordinates where I have started and at the same point I have ended my survey work, and that is known as a closed traverse. So and this closed traverse is of two types, that is link closed traverse and second one is loop closed traverse. In a link closed traverse, what happens? Suppose there is a point X as I have said, and I have start my survey work, and there is a point Y where I have ended my survey work. I know the coordinates of X and I also knew the coordinates of Y. So I have started my survey work and I have started my traverse from a known point, and I have ended my survey work at the known point, and it is known as a link closed traverse. In a loop closed traverse, what happens? There is a point here X where I have started my survey work and I have started my traverse, and at last where I have started my survey work, I have ended at the point where I have started my survey work, and there is a loop formation, and this is known as a loop closed traverse. So I hope you have understood both things. So please note, then we'll discuss some concepts, then we'll discuss the gate questions. So now we'll discuss what is latitude and what is departure. Suppose there is a line AB and the bearing is theta and the length of the line AB is L. So from coordinate geometry we know that if a line making an angle theta, so corresponding to that line, what will be this distance? from coordinate geometry simply known as L cos theta. ओके जिसके साथ एंगल करता है वो cos होता है, अल्टरनेट साइन होता है. आई होप यू हैव रिमेंबर दैट. सो corresponding to this line, that is cos, opposite side that will be sine. So length of this will be L sine theta. So what is latitude? Latitude is nothing but the projection on north south axis. This is north and this is south. And what is departure? Projection on east west axis. And what is latitude? Latitude equal to L cos theta. And what is departure? Departure is this, L sin theta. Note down these two things. Please pay attention. I will be discussing a very important concept. So I hope you have studied the coordinate geometry. So you know in the coordinate geometry this is x axis and this is y axis. So in the coordinate geometry, if there is a point, how I denote that point? I denote that point means x coordinate at first, then I represent the y coordinate. I hope you got this thing. So this thing means x is positive and y is positive. So first this is positive and positive. So in this case x is negative, y is positive, and in this case both are negative. In this case x is positive, y is negative. So this thing in coordinate geometry. But in the traverse survey we don't consider this thing. There is a different thing. So please don't get confused with this thing. So what we do in traverse survey? In traverse survey, this is north, this is south, this is east, and this is west. Suppose there is a point and this is a line L. So this is a point. So this thing is known as latitude. This is the bearing theta and this thing is departure. So how I represent this point? So in traverse survey, just see that we always write the latitude means y coordinate at first, then we write the x coordinate later. Means we represent a point in traverse survey like latitude, then comes departure. So I hope you got this thing. So this is the first quadrant. So the first quadrant is latitude is positive and departure is also positive. And this is the second quadrant, means latitude is negative, departure is positive. So these both are negative. So in this case latitude is positive, departure is negative. So I hope you have found the both differences, and this thing is in traverse surveying. In the coordinate geometry, we measure the angle in anti-clockwise direction. But in the traverse survey, we measure the angle in clockwise direction. Okay, I hope you found the both differences and don't confuse with this. We have to consider in the traverse surveying this sign convention. So please make a note. So I will again discuss that one thing, same thing. So this in the traverse survey, this quadrant is first, this quadrant is second, this quadrant is third, and this quadrant is fourth, and we normally measure the angle with reference from the north as clockwise direction. So very important thing, in the question he will give the bearing in the form of WCB or in quadrilateral system of bearing. You have to make an arrangement while solving the questions, we'll see that. So please consider this sign convention and fix this thing in your brain. So now for a closed traverse, summation of latitude equal to 0 and summation of departure means sum of all those departure values equal to 0. And for a loop closed traverse, sum of interior angles equal to 2n minus 4 into 90. You have to remember this thing, and there is a gate question asked from this formula. So note down this thing, then we will discuss further. Next, there is a point and I have start my survey work from this point, and I start the traverse survey. I continue the traversing process, and while continuing and before ending the traversing, I realize that I have started my traversing from here and I am ending at here. I am unable to meet the point where I have started my survey work. So this thing is known as closing error. So there is a error, this is known as error E. So magnitude of closing error E equal to summation of latitude whole square plus summation of departure whole square square root. And there is also the direction of closing error so tan theta equal to summation of departure divided by summation of latitude, implies that direction theta equal to tan inverse summation of departure divided by summation of latitude. So this theta is known as a direction of closing error, and E is known as a magnitude of closing error, that is summation of latitude whole square plus summation of departure whole square square root. There is one more term that is known as relative precision. So relative precision means what? So this means we will solve a gate question, and that thing will be more clear. So just now remember, relative precision means relative error of the closure. So what is the error? Relative error of the closure. Relative error of the closure, and this denoted as relative precision is given as error E divided by P. So what is P? P is known as perimeter of traverse. So please note down these three things, then we will proceed. So why this closing error has occurred means, while doing the traverse survey I must have made some error in linear measurement, and I have also made some error in angular measurement, due to which this closing error has happened, and there are methods to eliminate this closing error. The most two famous methods are Bowditch method and second one is transit method. The both two methods are important, but till now there is no questions from GATE from these two methods. So now we'll discuss about Bowditch method or Bowditch rule. So this Bowditch method is preferred when error in the angular measurement is more than the error in the linear measurement. Suppose I have started a traverse survey and I have started my traverse survey at A, but I haven't ended my traverse survey at A. I have ended my traverse survey at A dash. I was supposed to end my traverse survey at A. So I am having a closing error, and this magnitude of this closing error is E. And I can minimize or I can completely eliminate this closing error E by balancing a traverse using this Bowditch method. At first I am having a closing error E, now I have balanced the traverse using this Bowditch rule or Bowditch method. So this Bowditch method is preferred when correction required in angular measurement is more than the correction required in linear measurement. For linear measurement, error is directly proportional to square root of length L. L means length of a side of a traverse. And for angular measurement, this error is inversely proportional to square root of length L. So correction in latitude CL is given by summation of L into L by summation of small l, where small l is perimeter of the traverse, summation of L means total error in latitude, and L means length of a side of a traverse. So for example, for your understanding, so let me tell what is summation of L. Summation of L can be perimeter of traverse means length of AB plus length of BC plus length of CD plus length of DA. This is length. And what can be the correction in latitude? I can denote it as correction in latitude as CL equal to summation of L. Suppose summation of L means error in the latitude. Latitude means L cos theta. So adding all those things, whatever the error I will be getting, that will be summation of L. So that will be summation of L, where that is into L, small l by summation of L. So what will be L here? Suppose I am having a error in length AB and I want to apply the correction in this length AB first. So that will be length AB divided by this summation of L. So I can get the correction in latitude for this line AB. Similarly, I can find the correction in departure CD as summation of D into L by summation of small l. So while having this correction, I can apply the correction for both latitude of length AB and for departure for this length AB. This is the method is so lengthy, and in GATE they cannot ask the corrections for the entire traverse. If they want to ask from this Bowditch method, they will ask for a particular side of a traverse. They will be giving values and they will be asking for a particular side of a traverse. If they ask find the correction of length in the latitude AB, so while using this formula you can find the correction in latitude, then you can find the corrected latitude as length plus negative of this correction. Why this negative of this correction? We know that if error is positive means this is a closing error and this is a positive value, so correction will be always negative. So in the previous video also I have told you this same thing. If I am having a error is positive, so correction will be negative. So my corrected latitude will be L plus negative of this correction, and corrected departure will be D plus negative of this departure. So I can find the corrected latitude for all the sides. Then while adding all those things, I can find my closing error can be 0. So I hope how this Bowditch method is preferred. I will be using an example later, but in this video there is no gate questions from this Bowditch method, but please note in future I might take a question, or you can try from a textbook. So note a thing, you can also use the Bowditch method when accuracy level in the linear measurement is same as the accuracy level in the angular measurement. I can say that the amount of error I am having in linear measurement, if that is equal to the amount of error I am having in angular measurement, I can also use the Bowditch method. Unless and until in the examination, if until they specify the method, don't assume anything. See the method, whatever the method they are asking, and use that method and find the answer using that method. Now let's come to transit rule. Here in transit rule, angular measurements are more precise than its linear measurement. Means I can say that I am having less error in angular measurement and I am having more error in linear measurement. I can use this transit rule. So how I can find the correction in latitude? You can see this formula, and how I am find the correction in departure, you can see this formula. But there are slight changes in this formula. This L means latitude of that side, and this LT is sum of the magnitude of all latitude and without sign. So note this thing. Here same thing, d equal to departure of that side, and dt is sum of magnitude of all departure without sign, and rest I can find the corrected latitude and I can find the corrected departure. This thing will be more clear when in the later, I'll not in this video, in a later video, if I take a question and I'll solve a question using both Bowditch method and transit rule. So I have discussed all those possible concepts, and the remaining concepts will be discussed in the gate questions.